everyone, and welcome to today's episode of ZK Studies, where we are going to be taking a look at food chains. So first of all, what is a food chain? A food chain is like this diagram above. It is a network of organisms which rely on each other as a source of food. The food chain, therefore, demonstrates the flow of energy through an ecosystem. And there are different stages in food chains that are known as trophic levels. So first of all, we have producers, for example, plants, which are phototrophs, and they produce their own food through the process of photosynthesis. Next, you have your primary consumers, which are usually herbivores or organisms which only consume plants. After primary consumers, you have secondary consumers, and then you have your tertiary consumers. And these two tend to be carnivores or omnivores. And most food chains just have these 4 trophic levels. But sometimes you'll find that in marine ecosystems, there are up to 6 trophic levels. This is because there's a lot of sunlight available on surface waters, so less energy is lost at each stage. So whilst this diagram above is a food chain, we can also see food webs. And the same trophic levels apply. It's just that food webs are a series of interconnected food chains. Now at each trophic level, a certain amount of energy is transferred to the next. And this is 10%. So what causes the rest of the energy to be lost? Well, there are a couple of main reasons. Biomass can be lost through feces, or through urine, processes such as growth, movement, and homeostasis also use up this energy. Energy is lost through heat by respiration. And some parts of the organism just can't be digested. For example, bones of a carcass, or the indigestible cellulose in plants. So you might get asked a question about the efficiency of energy transfers at each of the trophic levels. So if that's the case, the least efficient energy transfer is going to be from your producer to primary consumer. This is because the most energy is lost. So if we're saying that 10% of the energy from each trophic level is transferred to the next, a 90% loss in the trophic level with the highest energy content is going to be more significant. Okay, so apart from food chains and food webs, we can also represent pyramids of number, pyramids of biomass, and pyramids of energy. So if I'm drawing a simple diagram over here, the different bar lengths could either represent the number of organisms at each trophic level, in the case of pyramids of numbers, so the bar length is proportional to number of organisms at each trophic level, and these can sometimes be misleading. So for example, if your producer is one large oak tree and the rest of the consumers are small ants, what we're going to have is a pyramid of numbers that is structured like so, where the producer actually has a smaller bar length. And that can be misleading, of course. Then we have pyramid of biomass and pyramid of energy. And in both of these, the shape will always be similar to a pyramid. It will never be inverted as we see in pyramids of number. So over here, bar length is proportional to the mass of biomass, or amount of biomass at each trophic level, and in pyramids of energy, the bar length is proportional to the amount of energy at each trophic level. So proportional to the amount of energy available at each trophic level. So there you have it. Pyramids of number, pyramids of biomass, pyramids of energy, as well as the definitions for food chains and food webs. And then, once again, we briefly talked about the methods through which energy is transferred from each trophic level.